We are finally ready, as we begin Chapter 6, to think about how to compare two different groups and decide for sure, once and for all, whether two groups are quote-unquote the same. Right? So we finally get to make that notion precise. And the way I want to start thinking about this is by taking a group that we all should know and love pretty well at this point, the additive group mod 6. So this is just the residue classes mod 6 from 0 through 5, with the operation being addition mod 6. And what I'd like for us to do is to think about, can I take a Xerox machine and run this group through that Xerox machine and get a carbon copy of that group out the other side that we can agree is somehow the same as the original? Right? And what would that kind of Xerox machine look like? How can I produce a group that has all the same properties that this group has, but which might have some superficial differences that we don't want to confuse ourselves with? Right? Because this is abstract algebra. The superficial differences don't matter. It's what's underneath. It's what's on the inside that counts. Right? So here's the idea. The way that we're going to put this group through a Xerox machine, or at least try, is we're going to pick up a function. So functions are now going to be the name of the game. Functions are the objects we're going to use to study similarity between groups, similar to how we use functions to study similarity between sets when we do set theory. So a function. And so the job that I want you to do, so this is how we're going to finish up today, real quick exercise, is to convene with your card-suited groups and apply a function to all the elements of Z6. And the function you'll use is the one listed over here by your card suit. And your job, if you can, is to draw what we call this hunters and arrows diagram for your function. If you're not familiar with what that is, or if you want a refresher, this is just a diagram in which, for example, if I'm the diamonds group and I look at the number 2, then f of 2 is going to be 3 to the second power mod 7. Right? 3 to the second power is 9. 9 mod 7 is going to be 2. And so if I'm drawing the hunters and arrows diagram for this, I would do something like 2 goes to 2. Right? And you would just do that for all 6 of the elements over here. Just figure out what f of x is, write it over here with an arrow connecting the former to the latter. So your job in your card-suited groups for the next 10 minutes is to apply your assigned function and decide whether or not the thing that you get over here is indeed a same group to Z mod 6. If it is, then what is that group? Do we know it by another name? And if it's not, why not? Why isn't it the same group? So 4 different Xerox machines, 4 different groups, but all putting the same thing into that document feeder on the top, right? Putting the same Z mod 6 in. What do you get out? Is it a same group as what you started? And if it's not, what are the differences? If it is, do we know it by another name? So let's quickly wrap up this initiation to this topic. Just by taking a look at each of these 4 functions that I gave you. So each of them had a domain of Z6, the additive group mod 6. What you probably noticed, I hope that this is true in each of your cases, is that the images of these end up being the numbers 1 through 6 in every case, every group, yes? But then it's the particulars that are going to vary a little bit. So 3 to the x mod 7, which of you had that one? That's you. So where does 0 go under that function? 1, and 1 goes to
3.
2 goes to
2.
2, okay. 3 goes to
6.
6. 4 goes to
4.
4. 5 goes to presumably 5. Okay. So there's the hunter and arrow diagram for that first function. Where's my 5 to the x mod 7? Which go? You're over there. All right. So 0 goes to the 1 for you also. 1 goes to 5. Where does 2 go? 2 goes to 4. 3 goes to 6. 4 goes to 2. And 5 goes to 3. Okay. So before we go on to the other examples, are these 2 functions the same function? Basic question. That's not the same function. How can we tell? What do they disagree on? Yeah, right. F of 3 in the first example, and the example on top is 6, but f of 3, no wait, they agree on f of 3. They don't agree on f of 5, for example, right? F of 5 is equal to 5 in the example up here. F of 5 is equal to 3 in the example down here. So they're not the same function, but what do they have in common? Okay, their formulas have this mod 7 happening in them. What other function property do these two have? All right, so say more about what overall properties these two functions share. Properties you might remember from a course like Math 180. So there's really only kind of two properties that we assign to functions on the whole in Math 180. One-to-one, onto. What can we say about these two functions? Are they one-to-one? How do we know? What would one-to-one mean? It would mean that no output over here is coming from multiple inputs over here, right? They don't have two arrows that are hitting the same target if my function is one-to-one. Is that the case for these two functions? Yeah. It is. Each one of these outputs is coming from exactly one input, right? So both of these functions are indeed one-to-one. What about onto? Onto would mean that every element in this target set is getting hit by some arrow. Is that true? Yeah. All the numbers 1 through 6 are getting hit in both cases. So both of these functions are one-to-one and onto. What's that combination called, by the way? Bijection. Yeah, these are bijective functions. So both of these functions are bijections. Even though they're not the same function, they have that same property, that important property, one with another. Let's review real quickly the hunters and arrows for f of x equals x plus 1. This is probably the simplest one to do. 0 goes to 1 goes to. Yep. And this one just is a ladder going straight down. 2 goes to 3, 3 goes to 4, 4 goes to 5, 5 goes to 6. What happens in f of x equals 6 minus x? It's just, yeah, it reverses. 0 goes to 6, 1 goes to 5, 2 to 4, 3 to 3, 4 to 2, 5 to 1. Okay. What can I say about whether those functions are bijections? They are. They're one-to-one and onto, but they're also different functions, one from another, right? So all four of these functions are different, but at least they are all bijections. They are one-to-one and onto correspondences between the elements of Z6 and the elements of this thing over here. So the big question, and this is the one I'd like to see some debate over the weekend on Slack, while you watch the daily work videos for Chapter 7 and begin your work on daily works 13 and 14, which I have for you on your way out, decide whether this list of elements 1 through 6 that you got in each of these cases actually is the same group as these 0 through 5. The key question being, if it were the same group, what is the operation in that group going to be? Right. So pick up a copy of your daily works on your way out.